Hi, all Chemmaster official YouTube channel followers. So here in this video, we are going to analyze 5 standard MCQs on instrumental analysis, which are given on our community tab. So my request is that watch the video completely to get the best analysis of each and every question. Okay, right. Now just look at the first question here. The correct eluting order of the following cations in a strongly acidic cationic exchange chromatography. So if you look at the given question, you have some information in it, that is the strongly acidic cation exchanger is given. Okay, and we have given with all monovalent cations. So to give the correct answer and to justify that answer, we need to look at the two effects. So in ion exchange chromatography, two factors can affect the retention of ions or elution of ions. Okay, so we consider the first one as the stationary phase effect, and second one here we can consider mobile phase effect. Okay, now just look at the stationary phase effect. Here in the given ion exchange chromatography, the exchanger is a strong acidic cation exchange resin. Okay, so just draw it. So I am just taking the example for it as SO3 minus H plus. Okay, a strong acidic cation exchange resin. Now, I'm just considering all the given monovalent cations as X plus. Okay, now the exchange takes place. So here SO3 minus X plus plus H plus. Okay, right. For example, if the interaction between the anionic functional group of the cation exchange resin and the cation is very strong, then what happens? Simply that means the cation retention time is more, because due to the strong interactions between the anion and the cation leads to the stability for that particular cation, and which stays in that column for a longer time when we compare with other cations. Okay, right. Now just look at here. All the given ions are monovalent. So which factor should be considered for their retention or for their elution? So simply we need to look at the size. So here lithium plus having, that means here I'm just considering bare ion size. Okay, so lithium plus is less than H plus, which is less than Na plus, and which is less than K plus. Now if the cation size is small, then what happens? It can interact very strongly with the negative functional group of that cation exchange resin. So lithium plus is having smallest size, bare ionic size when we compare with all other ions. That's why lithium plus make strong interaction with this SO3 minus, and which stays longer than all other cations. So based on the size and their interactions with SO3 minus of a strong acidic cation exchange resin, we can conclude that K plus elutes first and lithium plus elutes last. Okay, so this is the based on stationary effect. Now just look at the mobile phase effect. In ion exchange chromatography, and here if you look at the given metal ions, the best suitable solvent we can use is that H2O, water molecule, right? So whenever we take these ions in water, they will be hydrated. Now we need to look at the size of hydrated ions. So here the smallest lithium can hydrate much when we compare with H plus, when we compare with Na plus, when we compare with K plus. Can you give the reason for it? Simply, whenever the cation is small, then which can easily enter into the hydrogen bonding network of water. If the cation size is very large, then that cation cannot easily enter into the hydrogen bonding network of the water molecules. Okay, so whenever the lithium, that means the smallest cation, enters into the solvent, that is here water as a mobile phase. Okay, so lithium easily enter into the water and it can elute through the water. So when you consider mobile phase, so here the size of hydrated ions, so lithium plus is more than H plus, which is more than Na plus, which is more than K plus. So lithium plus elutes first, okay, when you consider mobile phase as water molecule, water, and K plus elutes lost. Now we need to consider the effect of stationary phase and mobile phase and which one dominates in eluting and retaining the cations in that ion exchange chromatography. So simply mobile phase is the dominating factor when we compare with the stationary phase. So that's why here we need to consider the effect of mobile phase, and from this we can say that lithium plus elutes first when we compare with, that means here the K plus elutes lost. So K plus is less than Na plus, less than H plus, and less than lithium plus. Okay, so option 4 is the correct answer. Got it. The next question. The best qualitative analysis method used to determine elements of atomic number more than 4 is. So the answer is X-ray fluorescence spectroscopy is the best qualitative analysis method used to determine elements of atomic number more than 4. Now, what is the importance of all other given 3 spectroscopies? If you look at atomic emission spectroscopy, it is the best method for the qualitative analysis of metals and metalloids. Okay, just take the notes. Now, atomic absorption spectroscopy is the best method. What I said, atomic absorption spectroscopy for metals and metalloids, and atomic emission spectroscopy for metals and metalloids and non-metals also. Okay, so atomic emission spectroscopy is the best tool for the qualitative analysis of metals, metalloids, and also non-metals. Now, capillary electrophoresis is the best tool or instrumental method for the qualitative analysis of ions. So here, can you give the examples? So ions of inorganic ions and organic ions. Okay, so for the given question, the suitable one is X-ray fluorescence spectroscopy. Okay, right. The next one. According to Beer's law for a colored solution, which one of the following statements is false? Now just look at the first statement here. The absorbance doesn't change when cell path length increases for the colored solution. Here just look at the specific mention. for a colored solution. Now I'm just taking the example here as copper sulfate colored solution. Okay, can you say its color? Copper sulfate exists in blue color. Okay, so the lambda maximum for this blue color of copper sulfate is at 600 nanometer. So for this, when we take a plot of so just say path length versus absorbance. Okay, now so I'm just starting from 0 centimeters. Now 0.2 centimeters, 0.4 centimeters, 0.6, 0.8, 1 centimeter. Now, so at 0, the absorbance is 0, okay? At 0.2 centimeter path length, that means after entering the incident radiation, so till to 0.2 centimeter distance, then it will show 0.3 absorbance. Now, by just increasing the path length to 0.4, it is 0.3. Now it continues till to 1 centimeter path length. And you can say that there is simply the change in absorbance by just increasing the path length is same. It is retained 0.3, 0.3, 0.3 only. That means the change in path length or the increasing in path length doesn't change the absorbance. So the first statement is the correct statement. That is the true statement. Okay. Now just look at the second one. The percent transmission is not directly proportional to the concentration. So just look at here the percent transmission. Now here we can take a mathematical expression from the Bees-Lombard's law, that is absorbance equals to 2 minus percentage of transmittance. So based on this equation we can simply conclude that the percent transmittance is not directly proportional to the concentration. So second statement is also the correct statement. Now just look at the absorbance directly proportional to concentration. So this is the wrong statement. Already we have analyzed it. Okay, so simply the absorbance directly proportional to concentration is the wrong statement. Okay, now so that is answer for us. Now solution should be diluted if the sample concentration is high. We know that according to Bees-Lombard's law, if the solution concentration is very low and if the solution concentration is very high, we can see deviations in the peaks. That means we can observe deviations from the Bees-Lombard's law. So the solution should be diluted to minimize the deviations from that Bees-Lombard's law. So here we can say that fourth statement is also the correct statement. Only the wrong statement here is the absorbance directly proportional to the concentration. Okay, right. And next question. The best method to determine moisture in an organic substance is. Here we have given with Kohl-Fischer titration. So simply Kohl-Fischer titration is the method to determine the water content in a sample. So we can so many aspirants can choose Kohl-Fischer titration as the answer, but here the question is the best method. So we need to choose the best one because Kohl-Fischer method has some disadvantages in which the volumetric method having only 50 ppm parts per million limit for titration to work. That means we cannot use Kohl-Fischer titration to find the water content, the samples which are having less than 50 parts per million solutions. Okay, right. Now So the best one is measuring the pH of the system, which is the simplest one and which gives the rapid and accurate answer. That means accurate determination of the moisture in organic substances. So option fourth one is the correct answer for the given problem or question. Okay, now which is not generally used for separation of proteins, as proteins get denaturated by it. So what you pick up from the given four options? So simply the correct answer is reverse phase chromatography. First, just try to know what is the protein denaturation. So simply protein denaturation means that the breakage of simple bonds like hydrogen bonds. We can see hydrogen bonds play major role in proteins. We can see different structures: primary protein, secondary, tertiary and quaternary protein structures. Okay, so the hydrogen bonds make a major role in those different types of protein structures. Yeah, here when you use reverse phase chromatography, can you say what is the mobile phase in reverse phase chromatography? The mobile phase is polar, whereas stationary phase is non-polar in reverse phase chromatography. Okay, so due to the polarity of mobile phase, which can react with the proteins, okay, that is the polar proteins, and which leads to destruction of hydrogen bonds of proteins. Okay, and so that simply leads to denaturations of proteins. So reverse phase chromatography is not the best one here, or not generally used for the separation of proteins, because the proteins get denatured by mobile phase, polar mobile phase, which is used in reverse phase chromatography. Okay, right, thank you very much, and we will discuss same, that means the 5 questions, that means standard 5 questions will continue on our community tab, and you can check the questions and you can try to answer the questions. And after completing 5 questions on each topic, we will do a video analysis on each of that particular topic. I hope it helpful for you, and please like the video and share the video, and what I say, so just subscribe the video, subscribe our ChemMaster official YouTube channel. And if you are further interested, you can visit and join the website chemmasters.online, or you can download mobile app ChemMasters from Google Play Stores to join the best concept oriented chemistry online courses. And you can also practice very high standard online test series from chemmasters.online. Thank you very much.